Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 15, 2025, which was released about 3 days ago. The big result is a new benchmark that poses realistic, time-consuming questions requiring reasoning across dozens, sometimes hundreds, of documents, where top frontier models only reach 61.2% F1. The paper is titled, MoNaCo, More Natural and Complex Questions for Reasoning Across Dozens of Documents. And, as we will see later, the implications for model evaluation are quite significant. Beyond the headline, the study provides 315 human-written questions with validated multi-step reasoning chains, and shows retrieval-augmented methods often degrade performance. Building on that, the tweets highlight MoNaCo as a new evaluation for stitching evidence across dozens of sources, averaging 43.3 documents per question, with one post drawing strong engagement at 123 likes. Alright, this scatter plot sets the stage. The x-axis shows how natural the questions feel to humans, and the y-axis shows how many evidence documents each benchmark typically needs. The green point sits in the top right, meaning highly natural questions that also demand many documents. The blue points cluster lower on evidence, while the orange points are less natural and still use fewer sources. The clear gap signals why broad, multi-document reasoning is the core challenge here. Next, this table grounds the benchmark with concrete examples across domains, and it quantifies difficulty using two signals, number of pages and number of steps. Notice how politics and demographics questions span hundreds of pages, 719 and 871 respectively, while still demanding several reasoning steps. Meanwhile, music shows 449 pages and a high 22-step decomposition, highlighting heavy aggregation. In contrast, culinary or literature entries use far fewer pages and only 3 steps, illustrating range from lightweight to expansive tasks. Okay, this diagram walks through the full pipeline end to end. On the left, target personas inspire realistic needs, like a history professor or an amateur chef. Moving right, workers write questions reflecting those needs. Next, the green panel shows decomposition, where a complex query becomes smaller sub-questions. Below that, answer annotation links each sub-question to sentences or tables from Wikipedia. Finally, the rightmost block executes simple operations like averaging percentages to compute the final answer. Now, this table summarizes the dataset at a glance. The top block lists properties of the complex questions. There are 315 in total, averaging 14.5 tokens, 37.6 decomposition tokens, 5.1 reasoning steps, and 45.3% requiring aggregation. Moving down, the intermediate layer shows scale, 90, 773 subquestions with 8, 549 lists, 40, 125 Boolean, and 42099 other. Evidence spans 36, 194 Wikipedia pages, with 29.5% sentences and 67.8% tables. Finally, per question averages are hefty, 43.3 pages, 66.5 intermediate questions, and 152.5 intermediate answers. Moving to the results, this table compares models on precision, recall, and F1 for complex questions. The upper block lists reasoning models, where O3 leads with 61.18% F1, balanced by 68.10% precision and 59.54% recall. DeepSeek R1 follows but lags in recall. The lower block covers non-reasoning models and the few-shot chains variant. Few-shot chains consistently raise F1, for example. GPT-4o jumps from 48.98 to 55.05, yet the gap to the best reasoning systems remains noticeable. Continuing from those results, 2 takeaways stand out. First, realistic questions that span roughly 40-plus sources expose brittle retrieval and weak multi-step aggregation, even for frontier systems. Second, decomposed supervision with intermediate steps helps, but recall remains the bottleneck. A decomposition is a step-by-step breakdown of a complex query. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.